Now, the first aspect of trigonometry that I'll be going into will be that of area of triangle. You would have already known that the formula for area of triangle is half times base times height, right? And we actually learned this sometime in primary school. So this is the first formula that we have been learning all this while. And beyond that, okay, when it comes to trigonometry, there is another formula called half AB sine C that we need to know. Okay, and today we are going to focus on this second formula. Now, how do we apply this formula half AB sine C? Okay, now A and B refers to two sides of the triangle, two sides. And C is actually the angle that is included. That means the angle that is between the two sides. So with that, let's have a look at some questions and we see how we can apply the formula. If we look at question 57A, we have this particular triangle and we have side AB given, we have side AC given, and we do have an angle between the two sides, that's 85 degrees. So from here, we can actually see that, we could actually allow A to be 7 cm, we allow B to be 10 cm, and the included angle, which is 85 degrees, that will be C. So substituting these values in, we could find the area of the triangle. Half, now A is 7, B is 6, C is 85. So from here, let's place all the values into the calculator. Let's do it together. And we will end up with 20.920 cm squared. And from there, because it's a running answer, we will round it off to 3SF. So 20.9 cm squared to 3SF. Okay. Now following that, for question 57B, C, D, do try it for homework. Now let's have a look at question E and F, which is slightly different from what we have just seen. So for question E, you realize that it's an equilateral triangle. Now equilateral because we are given these strokes on each side of the triangle, and this means that because the strokes determine the length being the same for each side, hence each side is actually 8 centimeters. I will annotate first. Alright, how about angles? Because all angles within a triangle is 180 degrees, and if all angles are equal, therefore one of the angle will be 180 degrees divided by 3, which is 60 degrees. Are we able to now find the area of the triangle? Now let's see here. Do we have two sides given? Yes, we have two sides. So this will form our A and our B. Our included angle, which is here, 60 degrees. So area of triangle equals to half A, B, sine C. Our C is 60 degrees. So now let's place our values into the calculator. From here, since our answer is running, let's round it off to 3SF. Alright, now let's refer to the very last question of the page, and you realize it's not a triangle. In fact, it is a rhombus, and the rhombus basically is a slanted square whereby all sides have the same length. How can we find the area of the rhombus? Unless we intentionally do something to it to form triangles. Then perhaps we can use half AB sine C. So what I would be doing is actually to draw a line from B to D, horizontal. And in doing so, you can see that I have formed two triangles. Two triangles that are identical. So with each side being 6 cm, and within a rhombus, opposite angles are the same. To find the area of the entire rhombus is really to find the area of one triangle first, and we multiply it by 2 to get the entire shape. Yeah. So area of rhombus, okay, 2 times of the area of the triangle. So it's 2 times of half AB sine C. What's our A, our B and C? Our A is here, our B, C is the included angle. Let's put these into the calculator. .7 cm squared to 3SF. Let's move on to the next page. So for the next page, question G and H is something that you can try. It's similar. You just have to consider what is the extra line that you got to draw in order for you to break the shape down into triangles. Let's have a look at question I. In question I, you realize that it is made up of a composite figure. I have an angle that is 123 degrees. This one looks like an included angle. And we have the two sides. So what we could possibly do is to consider drawing a line from B to E. Straight line. And if it's horizontal, it will be parallel to CD, which means that we are trying to form a rectangle and a triangle based on this composite shape. So, are we able to find the area of the triangle? Yes, we use half AB sine C. Okay, this one is to half AB sine C. And the area of the rectangle, that will be length times breadth. So this topic essentially requires us to remember the formula of different types of 2D shapes. I'm going to break this down into area of triangle plus the area of a rectangle. So for the first part, we have half AB sine C. And for the second part, we have length times breadth. So let's input these values into the calculator. We round it off to 3SF. Let's move on. For question J, it's something that you can do as well. It's made up of composite. It's a composite figure made up of smaller shapes. Let's have a look at question K. So for question K, you realize that there is a dotted line that splits the entire shape into two triangles. So within the first triangle, which is the right angled triangle, we can see clearly that we could find the area using half times base times height. Okay. But we have a question here. We have the angle, we have a length, and then just a length. Okay, which is the height. Can we find the base? So within this particular triangle, we have to use basic trigonometry, simple trigonometry, tua kaso, to find a missing length, which is BC. Now, how can we find that? So we can consider using tangent. Why? Because with 38 as the reference angle, 8.2 is the opposite, BC is the adjacent. All right. So tangent 38 degrees equals to, and from here to find BC, let's cross multiply. Hence BC equals to from here we can find the area of triangle ABC. Okay, and I truncate at 5SF. Let's move on to find the area of the other triangle. And within the other triangle, you realize that you are given one length, one angle that is included, but we do not have the second length. So how can we find the second length AC? We can consider using Pythagoras theorem to find the length of AC, which is the hypotenuse of the right angled triangle. Yeah. So in order to find AC, AC square equals to 8.2 square plus 10.4955 square. Hence AC will be the square root of it, which is 13.3189 cm. And can we find the area of this triangle now? Yes. So area of triangle ACD, half AB sine C. And from there, so to find the total area, we will need to add both areas of the triangle. One, 2, 6 cm square to 3 SF. So this working is rather long. You realize that it is not that challenging after all once we break down the shape into simpler shapes and we find individual lengths. So for question L, that's something that you can try as well. I'm moving on. For the next page, here we are asked to find the value of theta or x in each of the following figures. Now, again, I see the area given. That means we will have to consider the formula for area of triangle, which is half AB sine C. Do we have two given lengths? Yes, and it's the included angle that we need to find. Okay, we just have to take note one thing is that whether the included angle is obtuse or acute. When it is acute, it is less than 90 degrees. When it is obtuse, it will be between 90 degrees and 180 degrees. So in the case of the first question, you realize that theta is actually obtuse. Let's use the formula anyway. So area of triangle is half AB sine C, and my C is theta. That makes 9. Now if I want to find theta, that means on the left hand side, what is not needed is the half, the 6 and the 4, and we got to put it the other side. Now when we put it the other side, we have to ask ourselves, do we subtract or do we divide? So back to the left. Now how are these numbers, half and 6 and 4, related to sine theta? Are they being multiplied or are they being divided by? So half times 6 times 4 times sine theta on the left. When we bring it over, instead of times, we reverse the sign. We divide. So sine theta ends up being 9 divided by each of these terms, one after the other. 9 divided by half, divide by 6, divide by 4. Yeah? And we end up with 3 out of 4. So theta will be sine inverse of 3/4, and that will give us 48.59 degrees. Not to forget that when we have sine theta equals a positive number, it can be acute or obtuse. And in this question, what can we say about theta? Is it acute or obtuse? It's obtuse, right? So if it's obtuse, then we should not even accept the value of 48.59 degrees. This one ought to be rejected. And the correct answer would be the obtuse angle with respect to 48.59 degrees, which is 180 degrees minus 48.59, which will give us 131.41 degrees or 131.4 degrees. And this is rounded off to 1 dp. For all angles, it's always 1 dp. Alright, you can give question B, C, and D a try as well. Now let's move on to question 59. And these are applications where they ask you to find the area of the shaded part of the figure. I'll leave you to attempt this on your own. Question 60 as well. This is something you can do. Let's move on quickly to question 68. So here it mentions that in triangle ABC, AB is 4x cm and angle BAC is 100 degrees. Given that the area of the triangle is 480 centimeters square, find the value of x. So let's see, do we have two lengths? Yes, we do. Do we have an included angle? Yes, we do. Do we have the area? Yes, very much so. So let's apply the formula for area of triangle. Half AB sine C equals to 480. On the left hand side, what gives us half times 4 times 7? That will be 14. And what will x times x result in? That will give us x squared. So in order for us to find x, we realize that 14 is not needed on the left, Sine 100 is not needed on the left. We have to bring these over. Okay. And when we bring these over, what is the sign that we use? Again, on the left, the terms are multiplied with each other. So if they are multiplied and they need to be brought over, we reverse the sign to division. So 480 divided by 14, and we also divide it by sine 100 degrees. We will end up with 34.8146. Hence, to find x means that we need to square root this value. To 3SF. Yeah, so that's how we can solve a question on that. All right. That's all we have for area of triangle.